Hey everyone. Welcome back to our AI series. I'm so excited to have you here with me for another deep dive into the world of machine learning. Today, we're going to cover some really cool stuff: advanced machine learning algorithms, feature engineering and data preprocessing, model evaluation and validation, a hands-on tutorial for building your own machine learning model, and finally, hyperparameter tuning. By the end of this episode, you'll have a solid grasp of these advanced concepts and some practical skills to show off. So, grab a cup of coffee, sit back, and let's dive right in. And don't forget to like, subscribe, and turn on notifications so you never miss an update. Advanced machine learning algorithms. Machine learning algorithms are like the brain of AI applications. They help computers learn from data and make decisions. Let's explore 3 advanced algorithms that are super powerful: decision trees, support vector machines, SVMs, and neural networks. 1. Decision trees. Imagine you're playing 20 questions. Each question you ask narrows down the possibilities until you find the right answer. That's basically how decision trees work. 1. How they work. Root node. Think of this as your starting question. Splitting. Just like asking a follow-up question, splitting divides data into more specific categories. Decision node. Each new question that helps narrow things down further. Leaf node. The final answer, no more questions needed. 2. Pros. Super easy to understand, even for non-techies. Works with both numbers and categories. Minimal data cleaning required. 3. Cons. Can get overly complex and specific, which makes them prone to errors with new data. Even small changes in the data can lead to completely different trees. 2. Support vector machines, SVMs. SVMs are like an artist drawing a line to separate different types of objects in a sketch. They find the perfect line, or hyperplane, that best separates different classes. 1. How they work. Hyperplane. The best possible line separating different groups. Support vectors. The closest points to the hyperplane that influence its position. Kernel trick. Helps SVMs handle more complex data by transforming it into higher dimensions. 2. Pros. Great for high-dimensional data. Not as likely to overfit, getting too specific to your training data. Works well when there's a clear separation between classes. 3. Cons. Can be computationally expensive, so not the best for really large datasets. Choosing the right kernel function can be tricky. 3. Neural networks. Neural networks are like mini-brains for computers. They're inspired by how our own brains work and are fantastic at recognizing patterns. 1. How they work. Neurons. These are the basic units that process information. Layers. Input layer, data in, hidden layers, processing, output layer, result. Activation function. Determines if a neuron should be activated. Training. Adjusting weights based on errors to improve accuracy. 2. Pros. Can learn and model complex patterns. Adaptable to various data types and problems. Performance improves with more data. 3. Cons. Requires a lot of data and computing power. Often seen as a black box, because it's hard to understand how they make decisions. Prone to overfitting without proper techniques. Feature engineering and data preprocessing. Before we dive into building models, we need to prepare our data. Think of it like cleaning and prepping your ingredients before cooking a meal. 1. Feature engineering. Feature engineering is all about making your data more useful and informative. 1. Techniques. Creating new features. Combining existing features to make new, more informative ones. Transforming features. Applying mathematical transformations, like taking the log, to make data easier to work with. Encoding categorical variables. Turning categories into numbers using techniques like one-hot encoding. 2. Why it matters. Improves your model's accuracy. Extracts more meaningful information. Simplifies your model by focusing on the most relevant features. 2. Data preprocessing. Data preprocessing is like tidying up your data. It's a crucial step before feeding it into your model. 1. Steps. Handling missing values. Filling in or removing missing data. Normalization and standardization. Scaling features to a common range. Removing outliers. Getting rid of extreme values that can mess up your model. Feature selection. Choosing the most important features to reduce complexity. 2. Why it matters. Ensures your data is clean and error-free. Improves model training and performance. Makes your models more reliable. Model evaluation and validation. Once we have our model, we need to make sure it works well, not just on our training data but on new, unseen data too. This is where evaluation and validation come in. 1. Evaluation metrics. Choosing the right metrics depends on whether you're dealing with classification or regression problems. 1. Classification metrics. Accuracy. The percentage of correct predictions. Precision. The percentage of positive predictions that are actually correct. Recall. The percentage of actual positives that are correctly predicted. F1 score. The balance between precision and recall. ROC AUC. The area under the curve that plots true positives against false positives. 2. Regression metrics. Mean absolute error, MEA. The average of absolute errors between predicted and actual values. Mean squared error, MSE. The average of squared errors. Root mean squared error, RMSE. The square root of MSE, giving error in the same units as the data. R squared. The proportion of variance explained by the model. 2. Validation techniques. Validation techniques help us check how well our model performs on new data and avoid overfitting. 1. Holdout validation. Splitting data into a training set and a test set. 2. Cross-validation. Dividing data into k subsets and training the model k times with each subset as the test set once. 3. Stratified cross-validation. Ensuring each subset has a similar distribution of classes, especially useful for imbalanced datasets. 4. Why it matters. Provides an unbiased evaluation of model performance. Helps detect overfitting and underfitting. Ensures the model generalizes well to new data. Hands-on. Building a machine learning model. Now, let's get our hands dirty and build a machine learning model using Python and scikit-learn. We'll create a simple model to predict whether someone has diabetes based on medical data. 1. Install necessary libraries. First, install the libraries. Open your terminal and run. 2. Import libraries and load data. Next, we import the libraries and load the dataset. 3. Pre-process data. Now, let's pre-process the data by splitting it into features and labels, and then into training and test sets. 4. Build and train the model. We'll use a random forest classifier. 5. Evaluate the model. Finally, we evaluate the model's performance. That's it. You've built a simple yet powerful machine learning model. Keep experimenting with different algorithms and data to improve your skills. Introduction to hyperparameter tuning. Hyperparameter tuning is like fine-tuning a guitar. It ensures your model performs at its best by finding the optimal settings. 1. Why hyperparameter tuning matters. Optimizing hyperparameters can make a huge difference in your model's performance. Properly tuned hyperparameters lead to better accuracy, faster convergence, and improved generalization. 2. Techniques for hyperparameter tuning. 1. Grid search. Exhaustively searching through a specified set of hyperparameters. 2. Random search. Randomly sampling hyperparameters from a specified distribution. 3. Bayesian optimization. Using probabilistic models to find the optimal set of hyperparameters. 4. Gradient-based optimization. Using gradient descent methods to optimize hyperparameters. 3. Implementing hyperparameter tuning. Let's implement hyperparameter tuning using grid search with the random forest classifier. By optimizing hyperparameters, you can achieve a significant boost in model performance and reliability. Conclusion. And there you have it. We've explored advanced machine learning algorithms, delved into feature engineering and data preprocessing, discussed model evaluation and validation, built a hands-on machine learning model, and introduced hyperparameter tuning. Remember, continuous learning and practice are key to mastering machine learning. Experiment with different datasets, algorithms, and tuning techniques to discover what works best for your projects. Stay tuned for the next episode in our series, where we'll delve into even more advanced AI topics and techniques. Thank you for watching. Don't forget to like, subscribe, and turn on notifications for more insightful content on AI and technology. Feel free to share your thoughts and questions in the comments below. Happy coding!